Hi guys, so just a quick lesson on the radians and the circle. So there's some formula that we actually have to make sure we use radians so that our angle is in radians. So if we're given it in degrees, we'll have to convert it to radians, okay? We're going to look at those formulas now. So the first thing we need to do is have a quick recap on the vocabulary of a circle. So straight away I know that my outside circle, the outside is called the circumference. If I have a tangent, I'm talking about where it meets it at one point. Okay, so a line that meets the circle at one point. And the diameter is from one point on the circumference through the center onto another point on the circumference. Radius is from the center to a point on the circumference. A chord goes from one point on the circumference to another, doesn't need to go through the center. The segment is the part that cuts off, and a sector is between two radiuses and the included arc. Okay, and secant is a line that's drawn through a circle that creates a segment section, and it's part of it is called a chord. Okay, so the secant is like the extended chord through the circumference. Okay, the next thing that we just have to look at is just quick definitions. So an arc is any unbroken part of the circumference, and remember that an arc is only a fraction or a part of the circumference. And the sector is a plane figure bounded by two radii and the included arc. So I've already said that, so the two radii and then the included arc, so it's everything bounded by that. And a segment is the part that's cut off from the chord. Okay. When we're finding the arc lengths, we already did this in circular measure. So the formula was the angle at the center is equal to the length or the arc divided by the radius. Okay, so when we're finding the when we use the circumference for that, the angle on a full circle is going to be the circumference, so 2 pi r divided by r, so the angle at the center is going to be just 2 pi. That's when we saw that previously. So therefore, if I know that theta is equal to the arc length divided by r, I can rearrange the formula to give me the arc length is equal to the radius multiplied by theta. Okay, by bringing the radius over and multiplying it by theta. Again, L is the arc length, r is the radius, and theta is the angle measure at the center, but it must be in radians. Okay, so we can use that formula for the following examples. So a circle has a radius of 4 inches. So again, write down your key pieces of information. So my radius is 4. And the angle is given to me in degrees, so I'm going to need to change that into radius, and the angle is 240 degrees. So to change that into radians, I need to do 240 degrees multiplied by pi radians over 180 degrees, and then I can cancel my degree sign, and 60 goes into 183 times, and 60 goes into 244 times. So my answer then, my theta is now going to be equal to 4 pi all over 3. Okay, so now that I've changed my angle into radians, I can find the length of the arc by using my formula. L is equal to r theta, and remember that your theta has to be in radians. Okay, so L is equal to, my radius is 4, so 4 times my 4 pi all over 3, which is equal to 16 pi over 3, and we can leave it like that. So the length of the arc is 16 pi over 3. Okay, next one here, similar idea. My theta is 45 degrees, so that's the first thing that I need to change into radians. 45 degrees I know is 1/4 of 180, so it's pi divided by 4, or I can do this longer process over here, but I should still end up with the same answer. So 45 is pi over 4, it's one of those common angles. And again, to find, I'm told that my diameter is 16, so therefore my radius is equal to half the diameter, which is 8, and then I can just plug it into my formula. L is equal to r theta, so L is equal to 8 times pi over 4. The 4 and the 8 can cancel, both being divided by 4, so I end up with 2 pi. So the length of the arc is 2 pi. Okay. The next formula that we're going to look at is for the sector of a circle. So the sector of a circle we already defined as the region bounded by 2 radii and their arc, and the included arc. So this is my formula here. A is equal to half r squared theta. So again, that should remind you of the formula for a non-right angle triangle, finding its area. But instead of it being theta, it was sine theta. So if this was a triangle, I'd be doing half r squared times the sine theta. But for this one here, it's just a half r squared times theta because it's a sector. But again, they tell you the theta has to be in radians. Okay. So we're going to apply that now to an example. So I've got, given an arc length of 4 meters and a circle radius of 7 meters, find the area of the sector determined by the angle. So I'm trying to find the area of the circle, the area of the sector. So to do that, I need to get my pen working. A is equal to a half r squared theta. Okay, so for that formula I need the radius, which I already have, so my radius is equal to 7, and I also need my theta. Now I don't have my theta currently, but I was given one other piece of information, which was the length of the arc is equal to 4. Okay, so from the length of the arc I can find theta by doing the length divided by r, which is 4 divided by 7, so my theta is 4 over 7. Okay, and that was the formula that we had earlier on. So now I can plug it into my formula. So I've got A is equal to a half, my r squared is 7 squared, times my theta, which is in radians now, as 4 over 7. And when I multiply that out, I get an area is equal to 14 meters squared. Okay. So I was trying to find my radius, which I was given, and then I had to work out my theta with the other information. The length was equal to 4. Next formula that we're going to look at is the area of a segment. So it's that green part that we've highlighted. By considering two formulas that we have already used, you're going to try and find a formula for the area of the segment shaded in green below. Okay, and once you've found that area of a segment formula, we'll discuss it in class the next day. So please give it a go on your own. A couple of tips, two formulas that we've already seen. So it says that up here. And you also need to factorize to make it in simplified form. Okay, so that should help. Thanks, guys.